Hi, today I will show you how to bring up this 12-inch Riverdi display together with Toradex Verdin and Toradex Dahlia carrier board. We will do it properly by using device tree overlays. Let's take a closer look into our hardware. In this setup, we use a Toradex Verdin IMX8M Plus module. The module is mounted on the Toradex Dahlia carrier board. For the display, we use a Riverdi 12-inch display. The display is connected to the carrier board using a flat ribbon cable. The board is connected to the development computer through a regular Ethernet cable, an USB-C cable, and the entire system is powered using an external power supply connected to the carrier board. First, we install the build dependencies required for working with Linux kernel sources and device tree files. In the terminal, we install the basic development tools, the device tree compiler, and several libraries used by the kernel build system. These packages provide everything needed to compile device tree overlays later in the process. Once the installation finishes, the development environment is ready for the next step. Next, we create a swap file to increase the available memory for the build environment. This is especially useful when working inside a virtual machine with limited RAM, because kernel-related builds can require more memory than the system provides by default. After creating the swap file, we also create a dedicated working directory where all source code and build files will be stored during this guide. Next, we clone the Toradex Linux kernel repository. This repository contains the kernel sources used by Toradex BSP releases and provides the build infrastructure required for compiling device tree overlays. Cloning the repository can take some time because the kernel source tree is relatively large. In this video, the process is accelerated for clarity. After cloning the repository, we need to select the kernel branch that matches the BSP version used on the target device. Different Toradex BSP releases are built on different Linux kernel versions, so the overlay must be compiled against the correct branch. In this example, we use the Toradex 515-22X branch, which corresponds to the BSP version running on the Verdin module. Next, we clone the Toradex device tree overlay framework. This repository provides the build structure that integrates with the Linux kernel build system and allows us to compile device tree overlays. After cloning the repository, we switch to the branch that matches the kernel version used earlier. The device tree overlay framework must use the same kernel branch as the Toradex kernel sources to ensure compatibility. In this example, we select the proper branch, which corresponds to the Linux 5.1505 kernel used by the BSP running on the Verdin module. Next, we configure an environment variable that points to the Toradex kernel source tree. The overlay build system relies on the Linux kernel build infrastructure, so it needs to know where the kernel sources are located. We do this by defining the staging kernel dir variable and pointing it to the Linux Toradex directory we cloned earlier. To make sure the variable is available in future terminal sessions, we also add it to the bash rc configuration file. Once the kernel path is configured, we clone the Riverdi overlay repository. This repository contains the display-specific device tree overlay sources that will be used to configure the Riverdi display in this guide. Before continuing, we quickly verified that both the kernel repository and the overlay framework are using the same branch. This is important because the overlay build system must match the kernel version used earlier. Next, we move to the Riverdi overlay repository to locate the display-specific device tree files that we will use later in the build process. In my case, I initially tried to search for the files using a find command, but since the repository structure is simple, listing the directory contents is enough to locate the required overlay files. Next, we copy the Riverdi overlay sources into the Toradex overlay build directory. The Toradex overlay framework expects all overlay source files to be located inside the overlays directory, because this is where the kernel build system looks for them during compilation. First, we copy the main device tree overlay file for the 12-inch Riverdi display. Then we copy the additional display include files used by the overlay. After the files are in place, we open the make file and add the new overlay to the build list. This step tells the build system that the overlay should be compiled into a dtbo file. Now we try to build the overlay, but the build fails with an error saying that the kernel configuration is invalid. This happens because the overlay framework compiles overlays through the Linux kernel build system, and the kernel source tree must be prepared first. In particular, the generated configuration files such as autoconf.h and auto.conf must exist. To fix this, we switch to the kernel source directory, set the build architecture to ARM64 and configure the cross compiler. Then we install the Arch64 toolchain and prepare the kernel source tree so the overlay build can proceed. After preparing the kernel source tree, we return to the overlay build directory and run the build again. First, we clean the previous build artifacts and then run the build process once more. This time, the compilation succeeds. The overlay framework calls the device tree compiler through the Linux kernel build system and generates the dtbo file for our Riverdi display. At this point, the overlay binary is ready and can be deployed to the target device. Now that the overlay has been successfully built, the next step is to deploy it to the target device. To do this, we first connect to the Toradex Verdin module using a serial console. In this example, we use a PutTY configured for a serial connection at 1152.00 baud. Once the serial connection is established, we can access the Linux console on the module. After connecting to the Verdin module, we configure the network interface so the device can communicate with the development host. First, we check the current network configuration using the IPA command. Then we assign a static IP address to the Ethernet interface and bring the interface up. This allows the module to communicate with the host machine, which we will use to transfer the compiled device tree overlay file. Next, we configure a static IP address on the host computer. This ensures that the host and the Verdin module are on the same network and can communicate directly over Ethernet. In this example, the host machine is assigned the address 192.168.101, while the Verdin module was configured earlier with 192.168.102. With both devices in the same subnet, we can now transfer files between them. To confirm everything works, you can ping the 10.2 address from your PuTTY console. Once the network connection is configured, we transfer the compiled overlay file to the Verdin module. In this example, we use the scp command to copy the dtbo file from the development host to the boot/overlays directory on the target device. Since this is the first time connecting to the module over SSH, the system asks to confirm the authenticity of the host. After accepting the fingerprint, the file is transferred successfully. After transferring the overlay file, we enable it in the boot configuration. On the Verdin module, device tree overlays are loaded during boot based on the configuration stored in the overlays.txt file. We open this file using vi and add the name of our overlay to the fdt overlays list. This instructs the system to load the overlay during the next boot. If everything is ready, we just type reboot to restart our hardware. After rebooting, the bootloader applies the overlay and the display interface is configured according to the device tree modifications. Now you can see the hardware properly working. This completes the process of building and deploying a custom device tree overlay for a Riverdi display on the Toradex Verdin platform. You can find the full written guide and all source files in the description of this video. And that's it for this video. We generated and configured device tree overlay for Toradex module that it works properly with this 12.1-inch Riverdi display. And you can expect in one of the next videos that we will continue. And with the same setup of Toradex Verdin, we will configure touch on Riverdi 15.6-inch display. Thanks for watching and see you soon. If you are working with embedded displays, make sure to check the rest of our technical guides and tutorials.